Hi everybody, and welcome to the first video for the course. In this video I introduce programming itself to you, and then we talk about a couple of introductory topics like variables, arithmetic, and then we will talk about writing a couple of basic programs, and we'll basically do it in that order. So first I will define what a program is for you. That seems like a natural starting point in a programming course. And then I'll introduce just some basic stuff you can do, like printing, like giving values to variables, doing some arithmetic, and then writing a couple of first basic programs. Okay, so first, what is a program? There are different ways you could define it, but for us, this definition here will do. A program is a sequence of instructions that specifies how to perform a specific task, or perhaps many tasks. So colloquially, the best way to think about what a program is to think about a recipe. Okay, a recipe is just a sequence of steps such that if you do them in the right order, and you do them as specified, you will accomplish a certain task. So think about making a chocolate cake or something, right? A recipe says, well, first get a bowl and then put like sugar in this amount and then flour and so on, right? You do what the recipe says, and if you follow it to a T, then in the end, you've accomplished something. You've made a cake. So a program is like that. Presumably, you are writing a program to accomplish something, and we'll see the kinds of things we can accomplish here in a few minutes at the end when we write a couple of them. But anyway, you have a task in mind, so you write a program that tells a computer how to do that task. So you are writing recipes for a computer. And writing recipes for computers can be obnoxious because computers are literal and stupid. Okay, they have no room for nuance in how they read things. Okay, so anyway, a program is basically just a recipe. You are telling a computer how to accomplish a certain task that you would like it to do. So the first thing that you can have a computer do for you is print things. And so let me just show you how this works. So as we did in class, let me just show you how to get to a programming environment. So if you are on a PC, this will look a little different than on my Mac here. But you want to search for Anaconda Navigator on the machine and just have it open. And in any of these videos, almost all of them, I will jump back and forth between information and the actual programming environment where I will write code. I would encourage you to write code along with me while you're watching this. Okay, we'll make the material sink in a bit more. So when you open Anaconda Navigator, there are a bunch of options. For us, at the beginning of the course, we will always open Spyder. Okay, so S-P-Y-D-E-R. Later in the course, we'll use Jupyter notebooks here, but we don't need that now, and we will never need things like RStudio. Okay, so it's opening Spyder, and that will let me code. So once that's open, I can just minimize the Anaconda Navigator itself. Okay, so I have some pre-existing programs in here. So let me just go to let me go to an empty one. Thought I had this cleared out. Anyway, here's an empty program. Okay, there's nothing there right now. This green stuff, this is all commented out, which means it's just information the computer doesn't see. So it's telling me like, hey, I made this. There's nothing here that the computer actually sees. So on the left here, this is the programming environment where you will write code. On the right here is where the computer produces outputs. So if you tell the computer to show you something, the result of a program, it will do it over here on the right. Okay, so the print command, you write print, and then if you want the computer to print a message, like English, you put it in quotes. So like, you could give yourself a nice little pick-me-up here, right? You can tell the computer to tell you that it loves you, okay? So then when I click play right here, if you haven't created a program yet, it might ask you to save this somewhere. Okay, so if I were you, I would just save the file on the desktop or something. So my file is called untitled1.py. That doesn't really matter, just put it somewhere. Anyway, when I clicked play, notice what happened over here. It ran something, it ran a file, and the output was it told me I love you. How nice is that? If you want to augment that message, I love you so much or whatever, you can do multiple print commands. And the way that the way the computer reads this, it reads from top to bottom. Okay, so there's a line 1 right here, which it doesn't even see because it's commented out. There's a line 2 here it doesn't even see. Lines 3 through 7 it doesn't even see. The first thing the computer sees is line 8 right here. And then it will print, I love you. It will do that first. That's the first thing it sees, and it just goes from top to bottom in order. Next, it sees this command, print so much, that English. So it will also print that next. So if I hit play here, notice what it does. It ran a file, blah, blah, right? But for us, here's the output of the program. I love you so much. You can just have it print things if you want. Print just means have the computer show you, have the computer tell you. So, you know, it doesn't mean a whole lot, but I don't know. It's nice to see that message on the screen, right? I've now commanded the computer to do that. Again, you just keep adding on, right? And everything you add, it reads top to bottom. A magnificent McCune or something, you know. So now it will read line 8, then line 9, then line 10. It does them in that order. So if I like take this line 10 and copy and paste it or cut and paste it up front, okay, it will now do that first when it runs. Okay, so generally speaking, the computer just reads from top to bottom. It just does every command in order. There are exceptions to that we will see later, but that's how it works for now. You can also have it print non-English stuff. Like suppose you've forgotten what like 4 plus 7 is. You can tell it, hey, show me what 4 plus 7 is. And it prints all the previous stuff I already had, right? All that stuff is still there. And then the fourth thing it does is print what 4 plus 7 is. It's 11. And notice it didn't print anything here. Like there's an empty space inside the program here, but there's not empty space in the output. Most of the time, there are some exceptions, but most of the time the computer just skips empty space inside of a program. It doesn't really even see line 11 because there's nothing there. So anyway, with this print command, you can use Python like a calculator. So let me just have it print like, hey, what's 487, whatever, plus 687, whatever. If I ask it to print, it prints 1174. It just shows that to me, you know. So anyway, that's the first thing you can do. You can access to print stuff. Notice this is not in quotes because this is not an English thing to say. It's a calculation, right? I want it to do that summation there. So if I do this, if I put quotes on there like that, now it's going to print that English phrase. Okay, so watch what happens now. It just prints that, right? The literal English because it's in quotes. So in general, you can either just print raw English inside quotation marks like this, or you can have it print computations without the quotations. Notice the color changes. So now it's indicating to you, I'm not just going to print the string of symbols. I will do this calculation you asked me to do. So there you go. You can have it print things to the screen like that in that little output box. Okay, so next we'll move on to what a variable is. A variable is just something that's used to store information that will be of use in your program. So informally, a variable is like a box or a container that's actually in your computer somewhere. There's actually a spot in the computer's memory set aside for a variable, and you can put things inside that box. You can put numbers in there. You can put English in there, whatever. So variables have both a name and a value, both of which you control. So the variable itself is just like a box in the computer's memory. The box has a name. You use that name to find the box. Okay, it's like a label on it. Like when you go up in your attic or in your basement, if the boxes don't have labels on them, it's very hard to know what's inside of them, you know, like without just looking through all of them. Anyway, so every box has both a name, a label on the outside, and then stuff on the inside. And you control both of those. So let me just show you how that looks in Python. Let me clear this out. Okay, so consider a line of code like this. X equals 5. Okay, boom. That's line 9. What have I done there? What I've done is I've created a box or a container inside the computer itself in memory. That box is called X. Okay, I've given it a name. I've called it X. And what's inside that box? What's the value of the box? Like, what are the contents? The contents are the number 5. Okay? So again, X is like the label on a box. 5 is like the contents of the box. So now if I ask Python, hey, print X, like what is X? You know, show me. If I hit run, it prints 5. Okay? It prints the value. It shows you the contents of the box. Okay, so x is a variable, right? With name x and value 5, and I controlled both of those. I could have called this like box, and I could have given it a value of 43. And now if I ask Python to print, it's not box, print box, right? What is that? It tells me 43. It looks inside the box and tells me what's in there. Okay, so you can do that with numbers. You can put English in there. Like you can put just English contents inside your box. And now if I print, or if I ask it to run, it will print hi there. Like that's what's in there, you know. You open that box and there's a little message that says hi there. Okay, so that's what a variable is. It's like a container and you put things in there. And you can put whatever you want, right? So this equals sign, this is actually an assignment equals. You are placing contents inside that box. And notice, since Python reads from top to bottom, it doesn't see any of this. The first thing it sees is line 9. And line 9, Python's like, oh, this dude created a container in memory, a storage space. He called it box, so I know its name. And what did he put in there? He put in there hi there, you know? So then in line 10, after that's all done, I can ask it to print box, and it knows what I'm talking about. Since Python reads from top to bottom, suppose I do this. Suppose I ask it to print box first, and then later, you know, give it a value and stuff. See, it's confused. It underlines this. There's a little caution symbol there, undefined name box. It's like, what are you talking about? When I get to line 8, I have no idea what this box thing is you're talking about, you know? So again, it's important to remember you read from top to bottom. First, I create this storage space and give it a value. Then I can look inside there and see what's in there, you know? I can tell the computer, look inside there and tell me what you see. Okay, so we'll be dealing with variables a ton throughout the semester. So this is not like the final word on them, but this is just a basic introduction to them. Okay, you can do arithmetic with variables, like especially numeric variables, which I should have said a numeric variable is just a variable that has a number value. So back over here in my program, this box right now, this variable, is not a numeric variable because what's inside there is an English phrase. But if I do my 43 or whatever, that's now a numeric variable because what's inside there is a number. Okay, so anyway, once you're dealing with numbers, you can do things like add them, subtract them. You can multiply them, and multiplication is the star symbol. You can divide them if you want to, the division slash. You can also raise them to powers. You can do like a number squared or a number cubed or whatever. So let me just show you how that works. I can do things like this. I can say x is 10, y is 15. Okay, I've created two separate variables. Their names are x and y, and their values are 10 and 15 respectively. Then I can ask Python like, hey, print x plus y. Like, what is the addition of x and y? And, you know, when you add 10 and 15, you get 25. It just knows that, right? You can also do things like this. You can tell like, hey, z is a new box, okay? And what do I want you to put inside z? I want you to put x plus y in there. And I can tell it to print z if I want to. You know, you can create this middleman variable z if you want. And z, because it's the addition of x and y, has to be 25, and that's what is outputted over here. So you can add things, you can subtract them. Okay, x minus y will be what? Negative 5. It knows that's a negative 5 over here. You can multiply them. 10 times 15. Okay, so now z has value 150. And by the way, it's worth pointing out, you must include this multiplication symbol. If you're doing math homework, it's okay to write xy. Okay, it's understood there's a multiplication symbol in there. But notice Python doesn't like that. It gives you a little caution symbol, doesn't know what you're talking about. Okay, Python cannot handle that implicit multiplication. You gotta be explicit about it. X times y. You can divide them, you know. So 10 over 15 is 0.6666 forever, right? You can also do things like exponentiation. So suppose you wanted to do x squared. It'd be like that, x to the second power. And 10 squared is 100. So notice, by the way, normally when you take powers on a calculator, you do this little caret symbol. Okay, I don't know why. I didn't write Python. I didn't create Python. I don't know why they don't use the caret symbol, but it doesn't know what that means. Instead of a caret symbol, you must do two little multiplication symbols like that. Okay, so all that's to say, you can add, subtract, you can divide. So now we can actually do a lot. So let's now write a couple of basic programs. So let's write first, our first program, big moment. I should have had music or something for this. But anyway, let's write a program that calculates the area of a circle given its radius. Okay, something all of you can do, something you have done since 7th grade or whatever. But basically, right, if you know the radius of a circle, you also know its area, because area is given by that formula there, pi times r squared. So let's think about what that program would look like. Okay, given a radius, we have to calculate and then print so we can see it. Print the area. Okay, so let me come back up here. I control the names of everything, right? So I'm going to create a variable called radius. I could also call it r. I could also call it x. I could also call it McCune. I can call it whatever, okay? But since we're dealing with the radius of a circle, it seems natural to call this variable radius. And I'm just going to give it some value. Like I'm just going to assume a value of 8 right now, okay? I could come back and change it later if I want to. But for right now, my circle has radius 8. Okay, well then given my radius, how do I calculate the area? Well, the area is pi r squared, on some level, right? But the computer doesn't know what this is. It's already mad at me, So we have to be explicit. What do you mean pi r squared? Well, for now, let's just use the approximating value of pi as 3.14. Okay, there's 3.14. Times, you must use the multiplication symbol, times, okay? And then r in this program is not called r because I called it radius right there. So I'm going to call it radius. And then again, the caret symbol doesn't work. You got to use the double multiplication symbol. So now if radius is 8, what is area? Area is, by the arithmetic we know, pi times the radius to the second power squared. And now I can ask it to tell me, oh, what's the area, So Python just reads this top to bottom. Oh, the radius is 8. Okay. Well, then the area must be, because I've defined it this way, 3.14 times radius squared. So now area has a value, so I can print it. So if your circle has radius 8, the area is 200.96. Okay, well, what if your circle doesn't have radius 8? What if it has radius 6? Well, all you got to do is erase the 8, replace it with a 6, hit play, and now 113.04 is the area, okay? So given any radius, and you give it, right? You decide what the radius is right here, okay, where I'm highlighting. That's where you decide. Given any radius, this program will tell you what the area is, okay? Radius of 20, area is pi r squared. 1256.0. There you go. Here's a first program. It's an area of circle calculator given a radius. You control the radius, and then it does the rest of the work for you. Shows you. Notice, by the way, if I don't have this print area right here, if I take that out, if I run this, notice it doesn't show anything, okay? So when students are first writing programs, sometimes this will happen to them. They'll run the program, and it apparently won't do anything. So they'll call me over and say, hey, my program's not working because it's not doing anything. And my response is, it's doing precisely what you tell it to do. It's setting the radius to 20. It's then calculating an area. You, however, didn't tell it you wanted to see the area. Okay. Now your response is, well, of course I want to see the area. Why else would I do this? The computer should know that I want to see the area. But the computer's an idiot, It does exactly what you tell it to do. So if you don't tell it to show you something, it won't show it to you. Okay, so that's our first program. Let's conclude with one more basic program. Suppose you're taking a course. There are 2 exams and a final. Your grade is based entirely on those 3 things. Suppose each exam is worth 25% of your grade. The final is worth half. Ooh, that's a hefty final, right? So this is not our course, right? This is just some hypothetical course. Let's write a program that, given this information, this data, calculates your final grade. Okay, so what does that program look like? And by the way, this is something you can easily do on your own calculator. You don't need Python to do this, okay? These are just warm-up exercises. Okay, so to do this task here, to calculate a course grade, you of course need to know your 3 exam grades, right? Your 2 exam grades here and your final exam grade. Those are sort of the inputs to the problem, right? You need those 3 data points to calculate a final grade. So let's just give them some dummy values like we did before. Let's be optimistic, okay? Your exam 1 score is an A, 95. Exam 2 score, maybe you slip a little bit, 85. Final exam, you can name these whatever you want, but in general, you should be descriptive in your variable names, okay? So your final exam, let's say you get 100. You ace that thing, you know. Okay, so given those 3 scores, the question is, how do you calculate your final score? Okay, well, your final score is going to be your exam 1 score, but it's only weighted 25%. Add your exam 2 score, but it's only weighted by 25%. Okay, this is the classic computation that hopefully all of you have done in other courses, right? To calculate your final grade, you just take the category number, you know, exam number, and then weight it by whatever the percentage is. So exam 1's worth 25%, so you weight it by 25%. Exam 2 by 25%, final exam by 50%. Use a 0.50 if you want. Okay, so sorry, my text is so large that my screen ran out. Let me make this bigger. Okay, so here are my 3 inputs. I can control these numbers so I can tweak them however I want. However, the final score here, this is not tweakable, right? This formula is what it is by mandate, you know, because the first 2 exams are worth 25% and the final is worth 50. And then you can tell Python as a final step, hey, tell me my final score. So given these 3 numbers, what is my final score in the course? So if I run play here, it just reads from top to bottom. It fills in these 3 numbers, it does this calculation for you, this final score, and then shows you. So obviously your final score is high, right? Like it does pretty good, you know. Let's tweak this a little bit. What if you bomb the final, right? You only get a 50 on the final. What's your final score now? Only a 70, you know. Not so bad because these first 2 scores are nice, you know. Anyway, here's a program that will calculate a course grade for you given those 3 parameters, right? So one of the first things you can do in class, and I'll have you do this, is write a program that will calculate your course grade in here. Calculating your course grade in here is a bit more complicated because there are more categories, right? They're like daily quizzes and group projects and whatever, but the principle is the same. You just set up all the data, right, all the inputs, and then tell it what the final score is based on the syllabus weights, and then it'll just tell you what your final score is. Okay, so that's the end of this video. We've covered a lot, but also on some level not very much, which I guess is the nature of an intro video. So far, the things I've shown you that you can do in Python are things you can do on like a $5 calculator from Walmart or whatever. You know, this is not particularly impressive stuff here, right, in terms of what we can do. So throughout the course, we just keep adding more and more things we can do so that by the end of the course, you will be surprised maybe at the power of what you can do, okay? Python is incredibly powerful. It just takes building up of tools to unleash that power. And so far, we don't have very many tools. So in the next video, we'll start building some more non-trivial tools. In the next video, we will turn to what are called if statements. Okay, so that's the end for now.